Okay, so we're looking at 4.3 from Cambridge, question 7. And question 7 is interesting because it asks us to deal with sums and products of roots, but for a polynomial where it's given a specific relationship between them, and that is that the roots are in an arithmetic progression. So an arithmetic progression means that the roots are separated by some sort of constant, and that can be best represented by saying that you've got an example of that would be that you could have 3, 5 and 7, which are separated by 2. Now you could of course then go alpha plus a constant and alpha plus 2 constants, but we're going to be a bit more clever than that and choose the roots as alpha minus a constant, alpha, and alpha plus a constant. And the reason for that is because when we do the sum of the roots one at a time, the constants will be removed and we can determine alpha. So that's done by doing the sum of the roots one at a time, which is equal to minus b on a, so minus 27 on 18, which is also equal to a minus c, alpha minus c plus alpha plus c, which is simply equal to 3 alpha, as the c's cancel each other out. That means that we get alpha is equal to negative a half, which means therefore the roots are minus a half minus a constant, and minus a half plus a constant. So in order to do something else with that, we probably need to do the sum of the roots 3 at a time, or in other words, a product. So that can be represented as sum alpha beta gamma, which is 3 at a time, and that's equal to minus d on a, which is 4 on 18, and that is equal to alpha minus c, alpha plus c, and that's the difference between two squares, so we can make that alpha squared minus c squared times alpha. But we already know alpha from the previous equation, so that we can now get that 4 on 18 is equal to alpha squared, which is a quarter, minus c squared, which is still unknown outside of alpha, which is minus a half, which leaves us with, if we times both sides by negative 2, we get a quarter minus c squared, and if we times by negative 2, that goes to negative 8 on 18, which is negative 4 on 9. Okay, solving for c squared, of course, we can simplify that down to get c squared is equal to 4/9 plus a quarter, which is, we can do it on 36, which gives us 16 and 25 on 36, and I get c then as being equal to plus or minus root 25 on 36, which is equal to plus or minus 5 on 6. Now, it doesn't really matter whether we take a plus or a minus, and the reason for that is because the roots are already plus c and minus c, in which case that it makes no real difference what we take, because when we go plus and minus, 5 on 6, it just cancels out the plus and the minus in the roots. Anyway, the long and the short of that is that the roots are minus a half minus 5 on 6, minus a half, and minus a half plus 5 on 6, and they are minus 4 on 3, minus a half, and that one would be, what's that? Minus 3 plus 5 is 2 is a third. So they're the three roots of the equation.